Okay, so we're going to kind of recap this benchmark from the Florida State for our students, and we can see that this benchmark wants students to be able to estimate a population total, mean or percentage using data from a sample survey, and or develop a margin of error through the use of simulations. So here's one example, and this is the state example, so we'll go through it, and then we'll do another example that I just made up. So based on a survey of 100 households in Twin Lakes, a newspaper or the newspaper reports that the average number of televisions per household is 3.5 with a margin of error of plus or minus 0.6. So let's just understand that this symbol right here means plus or minus. It's two operations at once, high end, low end. So it's finding the minimum and the maximum potential. So the actual population, so that's what this means. And this is our value we are talking about. So therefore, we have 3.5 televisions per household with a plus or minus 0.6 margin of error. So we have 3.5 plus 6 or 3.5 minus, 0.6 and minus 0.6. I guess putting a 0 in front helps us kind of clarify for certain that we have that. And so the calculator will add that to be 4.1, and the calculator will calculate that to be 2.9. And that's why they say the actual population mean can be estimated to be between 2.9 and 4.1 televisions per household. Of course, we don't have 0.1 televisions in a household. It's just if you add up and divide, you end up with a non-whole value. Now, since there are 5,500 households in Twin Lakes, the estimated number of televisions is between 15,950 and 22,500. So how do they get that? Well, they take the household, right? They take that household number, and they multiply it by the number of TVs, right? And that's just multiplication, right? So the number of TVs on average is this number is the low end, so we'll look at the minimum first. So we take 2.9 and we multiply it by the number of households. And when we do that, you can use the calculator just to see 2.9 times 5500. It gets us the 15,950, which is the low end value. And we can find the maximum doing the same procedure, right? We take 4.1 because that's the high end of the margin of error, right? These are the margin of errors from that 3.5, and we multiply it by the same number of households to see that we get 4.1 times 5,500, and we still get the same answer that they had here, but that's just how they did it. All right, so let's take it to another situation where it's where it might not be as easy to figure out, but it's going to be the same thing. We have Jack and Jill are running for school president. A poll was taken to determine which of the two would win the election. A poll predicted that 49% of the students would vote for Jill. There was a margin of error of 2.5%. So we can do the exact same idea, right? We can say 49% plus or minus 2.5%. So we end up with 49%, and I'll do the minimum first, right, because we're subtracting. That's going to get us our minimum, and 4.49% plus 2.5%, that'll get you the maximum. And of course, you can use your calculator, but 49 minus 2.5 is 46.5%, and 49 plus 2.5 is 51.5%. Now, these are the range of potential voters. Now, we go a little further, and we can see that the population of the school was 1,200 students. What is the minimum and maximum number of students that would have voted for Jill? Well, all we have to do is take this number, 46.5, but as a percent, right, we need to convert it to a decimal. So you put percent over 100. Which becomes 0.465. And of course, the trick everyone has learned from early on in school is just to move the decimal over twice for percents. It's a useful technique, and so therefore the other one I would have 51.5 over 100. Just moving it over twice, I have 0.515. So we take this number, which is the percent value converted to a decimal, and we multiply it by the population, right? So again, we take the percent in this situation and multiply it by the population, and we do it for both. And so we have 0.465, let me move this up a little bit, 0.465 times 1,200, right? That's the number of students. And we do, right, we take the 0.515 and we multiply it by 1,200. So we have to do both. And so when we multiply 0.465 times 1,200, we see that there were 558 students on the minimum side that voted for Jill. And on the maximum side, 0.515 times 1,200, we have 618 students. So we know there is somewhere between 558 and 618 students that could have voted for Jill. And if it's a 50%, it is possible that Jill wins the election.